All right, so problem 5, 2019, question 4. Again, I think this type of question is a very fair question, and I would expect something similar to this as a great possibility of showing up this year. So, tumbleweed, commonly found in the western United States, is a dried structure of certain plants that are blown by the winds. Kochia, a type of plant that turns into tumbleweed at the end of the summer, is a problem for farmers because it takes nutrients away from soil that would otherwise go to more beneficial plants. Scientists are concerned that kochia plants are becoming resistant to the most commonly used herbicide, glyphosate. In 2014, 19.7% of 61 randomly selected kochia plants were resistant. In 2017, 38.5% of 52 randomly selected plants were resistant. Do the data provide convincing statistical evidence at the level of alpha equal 0.05 that there has been an increase in the proportion of kochia plants that are resistant? So first off, they're really nice. They told me I was working with proportions. I can sit there and look at this and go, hey, I have 2 samples. So I'm obviously working with a 2 sample proportion. Had they not told me that they're proportion, if they just said, hey, is there an increase in the number of plants that are resistant, I would still know that this was a test of proportion because they gave me summary data without giving me without giving me a standard deviation. If they only give me summary data, I need to have a mean and a standard deviation. They didn't give me that, so it can't be a test for means. But they were nice. They told me it's proportion. So I know I'm working with proportions. I have 2 samples, so 2 sample proportion. And please remember, all proportions are z-test, whether it's 1 sample or 2 samples or confidence interval. All of them are z-test. So in this case, P1 equals P2, and P1 is less than P2. But if you do that, you've got to define them. So make sure you always define your variables. So in this case, the true proportion of kochia plants that are resistant in 2014 versus P2, the true proportion of kochia plants that are resistant in 2017. The concern was that there are more that are resistant in 2017 than there are in 2014. So I'll just put this down here just for a little bit of explanation for you guys, not required. But 2014 we believe to be less than 2017, or that's the concern. Conditions. Well, we have 2 independent random samples. They told us they were independent. They told us they were random. Their one was taken in 2014, the other in 2017. Consequently, they should be 2 independent groups. We should be good to go there. The next one, we need to check the population size. And so we sit there and go, well, 61 divided by 0.1 is 610. I'm sure that there are thousands of these plants. So there's a reasonable to assume that there are at least 610 plants in 2014. Here, same thing, but dividing by 52 divided by 0.1, reasonable to assume that there are at least 520 of these plants in 2017. All right, so that takes care of whether or not we've, since we're drawing with sampling without replacement, that takes care of that issue. The next issue is whether or not our sample is large enough to use the normal approximation. Because remember, technically, if it's proportion, it's technically a binomial, but for hypothesis testing purposes, we want to use a normal approximation. And for that to be the case, our sample successes and failures must be greater than 10. And that, in this case, we have 2 samples. So it has to meet for both criteria for 2014 and 2017. Now, they gave me a percentage. They said 0.197 times 61. Well, that's approximately 12. All right. In this case, I rounded, and I'm letting you know when you're working with proportions, and you'll see this below, that X and N must always be rounded, round to the nearest value. Probability of, so these are the ones that were resistant, the ones that are not resistant. 1 minus 0.197 times 61, so 49 were not resistant. Over here, 38.5% were resistant in 2017 out of 52, so approximately 20. And 1 minus that value of 52 tells me that 32 were not resistant. All of these conditions, all 4 of them were met. and all four must be met in order to proceed. Because all four are met, both samples are large enough for us to use the normal approximation, so we can go ahead and proceed with what we're doing. So they told me this was 0.197. I solved, and I have x is 12. Both these values must be whole numbers. If you do anything else, your calculator is going to give you an error and you're going to get stressed out. Same thing here. Both those numbers must be whole numbers. Now, we actually did that in solve those right here. So we know we have them. But that's where they came from, was when we did our conditions in part 3. All right? So because we're doing a two proportion test for a hypothesis, we have to pool. Please remember, we do not do this for confidence intervals. We only do it for the hypothesis test. So in this case, we had 12 out of 61 and 20 out of 52. I combine those, and I get 32 out of 113, and that ends up being 0.22831. Now I can start plugging into my formula. So here's my formula, plugging in 0.197, 0.385 for 2017, so 2014 and 2017. Please note, this is not 2014, 2017. This is the combined or the pooled value over the 2014 sample size, the pooled value over the 2017 sample size. So to run the test, stats, test, two proportion z-test, 12 out of 61 were resistant in 2014. 20 out of 52 were resistant in 2017. Make sure my inequality matches what I have in my alternative, which was a less than, because we thought they were less resistant in 2014. And we end up with a p-value, a z-statistic of -2.2 with a p-value of about 0.0135, which is very small. So with a p-value of 0.0135, which is less than the alpha they gave us, and this time they gave us alpha, we're going to reject the null. So our p-value is 0.00135. We reject the null. There is sufficient evidence that alpha p equal 0.05 to suggest the true population proportion of Kochia plants that are resistant in 2014 was less than in 2017. Notice that I stated it just the way the hypothesis, the alternative hypothesis, was stated. So, in conclusion, it appears that Kochia plants are becoming more resistant. All right? Again, this is my simplified, not always required, but a really good thing to add. One last thing. We said we rejected. If we reject, the only type of error that could have been committed is a type 1. We don't have any reason to believe that we did. They didn't ask us about that. But because we rejected, if we had an error, it could have been a type 1. And the only reason I'm mentioning that is, once again, if they wanted to extend a problem in length, that would be an easy and relatively fast way to do that without adding a whole lot of time.